Okay. I liked Black Panther also. Great plot, fantastic superhero movie, and they discovered some new element called. Anyone remember what the name of the element? Vibranium or something like that. So appeal to the science. Okay, come. We must pay attention now. Just let me explain to you what we're going to be doing with these two periods. First period, we're going to go over momentum problems because your test will be primarily on momentum tomorrow. Okay, only momentum. And then the second period, we're going to do some chemistry. So we're juggling two balls at the same time because most of you can do those momentum problems, and we're going to go over question number 4, and we're going to show you how easy it was, and then when you get a similar question, okay, and I'm also giving you some momentum homework. Now listen to this. Listen to this. I can see a change in your attitude. I can see you guys are getting serious. You're realizing that it's going to take 3 times more amount of work to do the subject than you maybe originally thought. I can see you getting serious about it. It's not that the physics is difficult, but you need to work at it. So I'm going to every day give you a final problem. Like I'm going to give you another momentum problem today. I'm going to take it in. Don't lose. Thank you for we're going to join a WhatsApp group. I'll put all your names down. You can be able to ask me questions. Even if you need help today, you can ask via email. And anyone who's watching this video around the world is also able to ask. And we're putting these videos on YouTube so everyone can see. So, to get back to the point, so help is available. I'm giving you each day another momentum problem. I know you can do it, and when you see how easy question 4 was, you're going to say, you must get so good at it that you look at it and you laugh at it and you say, this is ridiculously easy. It's unusual that I can look at a question and just by mental arithmetic solve a matric problem, even without a calculator. And you'll see that that is just how easy that question was. So we're going to give you that for homework. Now listen, I need you to do homework. So I may just take this question in that you've done for homework, and that may count as your test. Or I may give you another question as your test. So the homework may be your test, or the question I give you tomorrow. How do you like that for them apples? Does that appeal to you?
Yes, sir.
But there's more. The marks have to be in on the 8th of next month. So we've got 2 weeks. I can do this every day for 2 weeks. I can get you doing a question for homework. If nobody does that question for homework, I definitely include that in the year mark. No, but sir, that's so nasty. No, but you're going to have my name to ask questions. I'm going to make sure I'm not going to give you a question that you can't do. And I want you to do homework. And I know people who do homework do well in matric. So even if nobody does the homework, well then it just shows. One test for chemistry, one for physics. But I may give you 4 questions. They don't say how long that test is going to be. And you know me, I love marking. So I may include all homework and all test questions, or maybe just 1 or 2 of them. You're not really going to know. So let's hear if there's any opinion on that. What I'm trying to do is I'm trying to get you to do homework and to be prepared. And that
So when I'm going to finish our practical?
Second period. No. Okay, so second period we're going to do chemistry and finish your practical, your results. Okay, first period, let's get the momentum question and your homework going. Yes?
What's your YouTube channel?
Just say that again. What is my YouTube channel? I will give you that on our WhatsApp group. But if you Google Stephen Thomas Physics Fun Momentum, I'm the first guy that comes up. So, and I spell physics like this: F-I-S-I-C-S, and fun, P-H-U-N, Thomas, and say momentum.
So you like?
When I come up, I've got about 70 videos
So you like?
covering the whole
You
matric
like
syllabus.
download like for this stuff?
I've got 70,000 views. If that's a lot. I don't know. So,
So now how do you expose like that?
sorry,
How do you get exposure?
you just make 70 videos and you get 1,000 views for each video. So like these videos are going up, and some person might be interested to know what Wittewormer High School's lessons are like. They'll say, yeah, we like it, we might copy one or two things, or we hate this guy's, I hate his teaching method, and then they'll say, don't do it like that. But let's try it out. Now, I just want to hear your opinion because we're doing this for you, not to you. Are you guys cool with the idea that your homework, that may be the easiest way to get a high test mark? You do your homework. It's all stuff that you can do. If you need help, you ask, and then you hand it in, and that may count. I may not even give you a test tomorrow, or I may. Are you cool with that idea? That your homework may. Sure. No, we're only doing physics for now, test. So your homework may count towards the test, or I may count it and another question similar to the one that you did. So you don't like that, Fakile, why don't you like that idea? The homework, why wouldn't you like your homework counting towards your first term mark? You make a lot of mistakes in your homework. Yeah, but sometimes, Fakile, your homework has got to be 100%. So, do you think if I gave you a physics test tomorrow, you would get a lower mark than having like an open book opportunity to go home and use your textbook and everything and even ask me online? Do you think you're going to do better in a closed book test than in homework? I'll tell you what, Fakile, the most important point is this. I need to get some means by which you all are doing homework seriously every day. But 20 minutes, each question is 20 minutes. I'm not giving you more than 20 minutes. If it's 20 marks, it's 20 minutes. I'm not giving you more than 20 minutes, and matrics, you see, have to be used to doing 20 minutes per day. There's no less than that. So you will probably find, after I've gone over question 4, you'll find it easy, then probably this next question you'll find easy. If I see that most of you are still, here's the learning curve. If I find that most of you are there, I may not count that test. However, if I find that most of you are not bothering to hand that homework in, I definitely will count that test. So the point is, if I see that you're growing every time we do a question, getting better and better, then I'll count your last test. But I don't want to see, if people are not doing the homework, A, I might count it. B, I'm definitely phoning their parents. Right here from class or when I get home and saying, you know that your son, daughter didn't even try the homework. And here's my home number. I will write my number. I don't want to put it on the whole World Wide Web, what my home phone number is, because someone's going to phone me from New York. But I'll put my home number as well. You can even phone me. Like, we can just chat, but don't phone me after 9 o'clock because I'm in ZZ land. I'm asleep. So I'll put my number there. You can also ask questions. Does that sound fair? And you'll be the first student who ever phones me at home. So please phone me. I will never think less of you. I'll think, great, this is all. I'll give you my number, but I just want to make sure that nobody can see it. I'll put it when I'm not recording. Okay. Now, let's quickly, if you don't mind, go over question number 4. Okay, now, I'm glad to see you guys are beginning to get serious about I can see before you were disinterested, but now get the answers to question 4 and see how easy it is. Happy with that, everybody? Okay. Question 4. Here's the question. It came from last year's matric exam. First question, 4.1. Define momentum. Okay, define it.
The amount
What is it?
that an object is.
It is
The amount of motion that an object has due to the product of its mass and velocity.
nothing. So simply it is mass times
Oh,
velocity.
did you want the formula? I thought you wanted the word thing.
No, I want the words, but the words are just simply mass times velocity. That's momentum. Was that difficult? It's
So
on
we
your,
say that in the
it's
exam,
on
we
your,
get the
yeah,
answer.
it's just mass times velocity. It's on your data sheet, P equals NV. Second question, so that was 2 marks. Mass velocity, 4.2. Will the girl roller skate combination move to the left or to the right?
To the left.
Who says left?
To the left because of Newton's
To the
third
left,
law.
to the left. Isn't there a song like that?
Yeah.
Okay, you see I'm not as square as I look.
Newton's third law was
It's
for every
Newton's-
action is an equal and opposite reaction.
I love, thank you very much, Michelle. So here's the girl. She's on her roller skates. She throws the box this way. Newton, which one?
Newton's third law.
3. She goes that way.
Yeah.
Let's see what they ask. Will the girl roller skate combination go to the left or the right? Name the law in physics that can be used to explain your choice of direction. It's Newton 3. But is there another law I could use? Yes. What is the other law that I could use? I haven't checked the memo, but I know it's also correct. Who can come up with another law? Are we giving positive momentum here? Is that positive momentum? So what must this momentum be? This momentum must be negative momentum. And what do we know? Now listen to this carefully. Cassian, I'm putting you on the spot. What was the sum of the momentum before? She was standing there with a box. Okay, I'll use a helmet. She was standing there with a helmet still at rest. What's the momentum?
0.
Yeah. So then afterwards the box goes that way. That's got positive momentum. So she must have negative momentum because then the sum of positive and negative momentum is still 0. So you could also use the law of conservation of momentum, which says momentum in a closed system, the total linear momentum in a closed system is conserved. Those are your 2 possibilities. Okay, tell me, was that easy? And then, will you have you written it down?
Yes.
So we can use Newton's speed or sum of P initial, what's it equal to? What's the law? How do you summarize it? Sum of P final. I could use, but I may have to explain that.
Yes,
Does it make sense?
how can you say?
Do you understand why I'm saying that the law of conservation of momentum could be used to explain why the girl moves to the left? Who feels like explaining it? Why the girl goes to the left if the momentum of the box is to the right? Thanks. Okay. Explain, please.
So basically,
Do you want to come up here and just say it nice and loud if you don't mind? And thanks for volunteering. Okay, just say it nice and loud. Why?
So basically, if you look at the girl, when the box and the girl is together, then it's zero, right? The momentum is zero. But now, as she throws the box to that side, that means it's going to be positive, right? And now she will automatically move to the left hand side in order for it to be equal. So basically, the total sum of linear movement has to be conserved. If the girl goes to the right hand side, then the zero is not going to be zero if she goes to the right hand side, but if she goes to the left hand side, the positive and negatives are going to cancel, so therefore the total linear of momentum that was there in the beginning is conserved at the end.
Give it a clap, guys. That's better than that. Much better. Oh. You can do that. Oh, that's much better. Okay, it means we can put 40 in the class. Should be able to get 4 at the. And they can also sit in groups more closely. That's fantastic. Okay, then next one. 4.3. Calculate the mass of the girl. Okay, we're still recording. Okay, what formula? Then the letter. Do you know the formula we use for all momentum problems? Will you be able to write it down? Do you want to come and give it a go? If you don't mind? If you can do it from memory, fantastic. Then you're well on your way to. So it's the same as this, but it's fleshed out. So everybody just write down that law and give it a go. Lovely. M1. V initial. Fantastic. Okay, could somebody maybe cut these up with a ruler into, maybe 2 people can help, because they, so you just drag that. Sorry, it's Timberlake, right? I called you Linda. Lalisa. That's Timberlake. Now, guys, can all of you write this formula without looking? Because it's not going to come in the exam tomorrow.
Yes, sir.
Yeah. All of you write it? Did you write it down? Faster than me? Okay, let's see if it's correct. M1 VI1 plus M2 VI2 equals M1 VF1 plus M2 VF2. Wonderful, Lolita. If you've done it like that, you remember it, you're well on your way to getting your marks. Okay, well done. Sorry. This you're getting in tomorrow.
I mean, the types of questions.
Only the questions we've done. Okay, now we've got the formula, now we're going to plug in our values. Okay, what did I ask you guys to do, especially while you're like little birdies learning to fly? Write all the values here. Okay, so that you don't get confused. What should we call M1? Jamie, what should it be, the girl or the box? Okay, Jamie says the box. And Jamie, what is the box's mass? Okay. Right? So then, does it make sense that we write all the values first? Okay, what is the mass of the girl? N2. Unknown. So what do we put? Right. What's B initial 1? What's B initial 1? 0. Because it's not moving. B initial 2, and this should be meters per second. Who would like to tell what is B initial 2? No.
It's 0.
The box is not moving and the girl's not moving. B initial M2.
So if I give this, if I give everybody one of this,
What is B final 1? 4. If you chose your box as the positive one, or mass 1. Now let's just stop there. That's as easy as it is? Does everyone understand that you put your values down, and now we've got to calculate what is B final 2 equal to? Now that's the goal.
Yes, sir.
What is the girl's final velocity? They give it to us as 0.6 meters per second. 0.6 meters per second. Great. Now, Cassie? She's made the most important point where you can get lost here. If the box is plus 4, the girl is minus, because she's going opposite to the box. That's the only place you can get lost. Tyree, does that make sense? Did you get minus? Did you get the minus and plus? Okay.
so I'm going to put the sign here.
Now we've got everything listed. We plug it into there, and there's our answer for the mass. What is it? The mass of the girl.
Yes, sir.
What did the answer come to? Now, do you think that I'm going to waste mine and your time doing the maths?
No.
When you can just go and plug those into this formula, and what was the answer?
So I got
53, comma 3
kilograms per meter per
Sign,
second.
just bear with my mistake.
kilograms. Lovely. I trust that you can all turn the handle and get the answer. Happy? Linda Legend, happy? You're not in a daze there, this was easy? Was it easy? We chose the same formula we'll always use. We wrote our values. Now, another reason why we write this down, is because what are we going to check? We check our signs, but we also check our units that they are SI units. They've got to be Sistine International units. So if they were in kilometers per hour, we've got to change it to meters per second. Do you see why I prefer we waste a few minutes and write our values down, write our formula down, and then plug the values in? And everyone can take those, plug them in here, and get the answer. Okay, now let's go to 4.4. 4.4. Calculate the magnitude of the impulse that the girl roller skate combination is experiencing while the parcel is being thrown. So now, what are our two formulae for impulse? Hands up. Thank you.
I is equal to change in V.
Sorry, just say that again.
I is equal to change in V.
I. Impulse. Okay, what is the symbol for impulse? It's change in P. Not I. There's no I. I is amps in electricity, so don't use I. Delta P equals M delta V or delta NV, or what's the third possibility?
So PF minus PI.
Or
PF minus momentum final minus
P
momentum initial.
final minus P initial, lovely, or force times time. Those are your all the same thing for momentum, for impulse. Is there anything I've said which you don't already know?
So the middle one is the best. You just solve the.
Now let's solve, calculate the magnitude, and this is 3 marks, 4.3. Now, let's do it mentally. Shall we do it mentally? Yes. And the box had 0 momentum to start off with that. I love 0. I can subtract 0 from anything. What was its final momentum? So if we use P final minus P initial, we can find the change in momentum of the box. So what was the box's final velocity? It was, this was 8 kilograms and it ended up at 4
So it's 32.
meters per second. And right is positive. So, Anna, am I right in saying that you can probably work out 8 times 4? If not, you reach for your calculator. Everybody, what is 8 times 4? So what is the impulse or change of momentum of the box? So we say here, change of P box equals P final, are you taking this down? Minus P initial. What is P initial? P final is 8, is N times V final of 1, V final 1, minus N V initial 1, which is going to be equal to 8 times 4 minus 0. And that is 32 kilogram meters per second to the minus 1. That is the unit for change of momentum.
So can you go over it again?
Sure.
So
Sure.
I think we should go.
Okay,
Okay, I see now.
should we do it just once more?
Yes, please, sir.
Okay, look how easy that was. What was the final momentum of the box? It was 8 times 4. What was the initial momentum of the box? 0. So what's the change? 8 fours are 32 minus 0. Because it was n times 0, which is 0. It had 0 velocity, so it had 0 initial momentum. Do you see how I can do that by mental arithmetic? Now that was the change of the box. So what is the change of the girl? It's opposite to the box, right?
So it's going to be negative 32.
So if the box is positive 32, the girl must be negative 32 to keep the total momentum at 0. So therefore, what are we going to say finally here? We're going to say, but P girl is equal and opposite to P box. Therefore, P girl
It's negative 32.
equals minus 32 kilogram meters per second to the minus 1. Do you see how easy that is? So if we gave you this exact same question with different figures tomorrow, you'll be able to do it. Are you glad we go over these problems and then you see how easy they are, then you cope with them?
Impulse need a direction.
Impulse has a direction, and in this case, it's left or negative.
So do we say left or do we just write the sign?
No, you write the sign and then you interpret it for the examiner, or left words. That's the best you can do. Don't just leave it. If you rather do everything for the examiner, let him know that you're really on top of it. How's it? You well? What are you doing here? Fantastic. Nice to see you.
Sorry, sir. Are there also questions, sir?
You know, you didn't use a lot. I had already given you those names, and then I marked them. And I gave you a mark for names I gave you. That's why you didn't lose a lot. Okay, and last, 4.5. Without 4.5. Without any further calculation, write down the change of momentum experienced by the parcel. Well, haven't we already worked it out here? So the change of the momentum of the parcel was plus 32. How do we know that? Because parcel's momentum is opposite to girl's momentum. Okay. Who wants to explain why parcel's impulse is the same as girl's impulse but opposite? Who wants to explain it? Someone from this side. I don't want to call you up. So Nenny, do you understand why the parcel's impulse is equal and opposite to the girl's? Would you? Sakile, come. Give us a go. Do you understand why the parcel is opposite to the girl? Just come and explain it if you don't mind. Okay. Okay. Let's say it once last time. Total momentum to start off is 0. What's the total momentum to end off with? 0. Parcel got 8 times 4, 32 kilogram meters per second positive. So girl must get minus 32 to make minus 32 and plus 32 come back to 0.
So,
and that's what you explain.
In a real life situation, how if you look at it, like if you see it, so how do you actually know it? Momentum was concerned.
Okay, just one last point before we go. I'll answer your question. Let's give you a real life problem. Has everyone copied this down now with the answers in the book? Okay, I'm just going to take a little piece here. Let's take a real life question. Here is a car. Here's a car. And it's traveling that way and it hits a parked little car here. Right? And then afterwards you find both of them are sitting like this. Okay. Do you see that is a real life situation? We've got a big SUV, it's a little Mini Cooper. Parked. This one's going, this one is stationary. This one's got momentum, that's got nothing. This one's got a certain mass, say 2 tons. This one's got a certain mass, say less than 1 ton. Now, there's a big crash because the guy's on his cell phone in this SUV. Right? So there's the SUV. Now they're going to work out how fast this guy was going. So what do? They measure the distance from the accident where all the glass fell, and they work out the momentum that this original truck SUV had to have caused them both to have moved off, stuck together afterwards. And that's a real life investigation. They use momentum to solve how fast this guy was going. If they see skid marks, they know he was going fast before he hit it. But they can even tell from how far the 2 cars go, how fast he was traveling. And there's a momentum example. So that's a real life example where they use it to solve insurance claims. Did I answer your question? I've forgotten what the question was.
So I was making a reference to the government and
yeah.
Like if she really had a thing in her hand, like a box in her hand, so but I'm asking not if actually know it? What the law says is true, sir. Like, how would you know it? It's equal.
That the law is true.
Yes, sir. Like, if you look at.
Okay, if you and one or two others are up to date with, let's say you answer this question I'm going to give you, right? And you finish it for homework. You finish it quickly. I've got an experiment I want to do on camera, which you can use to demonstrate the law. Now, I made a video of this exact same thing, but not with learners. So what we did was, just to tell you what you're going to do, if you've got the time, and I want to do it, we're going to weigh 2 cars. Okay, so here's the one car, and we're going to weigh the other, and we're going to actually prove to you that the law works. I've got a bit of string tied up here, so that's just hooked onto that. Okay, so here's our set of scales. Now, if you've got the time, you see they balance, there's nothing in there. We're going to weigh this car. Okay, so there's that car. And how are you going to weigh it? And you're going to prove that the law of conservation of momentum, it works. Where is my maths box? Okay, so we've got weights. I don't have real weights. I do this at home. So here's a weight, and I know that this is 50 grams. If we put this in, and it's heavier, then we know that that car is lighter than 50 grams. So we must use something else, right? Happy with that? So we weigh it. So what do I use for the something else? I've got a whole lot of 5-cent pieces. And each 5-cent piece weighs 4.5 grams. So I start putting in 5-cent pieces till it comes level. Happy with that? One more. Okay, it's a bit too heavy. So if I don't have 5-cent pieces, I use 10 cent. And those are 2 grams each. Okay, so now I've weighed it. How much does it weigh? It weighs 1, 2, 3, 4 5-cent pieces and 1 2-cent piece, which is 4 times 4.5, which is 18, plus 2, 20 grams.
Yes.
So that weighs 20 grams. Happy with that? Then we weigh my second little car, which is this one. It's heavier. That weighs definitely more than 50 grams, I think. Then we take this ruler, we tie it with a piece of string, right? I've got a piece of thread, so you guys are going to have to do it for me. You tie it. Happy with that?
Yes, sir.
We put the 2 cars together.
Oh, yeah.
They start at 0.
The one with the less mass is going to move at a higher velocity.
The one with the less mass is going to move left or whatever with a higher velocity than the one with more mass. And then we multiply mass times velocity of this one and mass times velocity of that one, and they should be the same but opposite. So we tie it with a piece of string and then we burn it so that we don't have to touch it. We burn the thread with a butane lighter. You see, here's our organics. That's butane. Methane, methane, propane, butane. It's a liquid. You can see it in the little tank there. So now we're getting a little bit of organic mixed with it. And then what we do is we film it. We put it on YouTube, the explosion, right? And then on YouTube, 30 frames is 1 second. So we write on the desk, we draw a ruler, we mark 10 centimeter intervals. It sounds like a lot of work. We film it and then say it goes 30 centimeters in 1 second. We know its velocity is 0.3 meters per second. Right, or 30 centimeters per second, which is 3.3 meters per second. So that one's going 0.3, that one's going 0.2. we got our mass, we got the velocities, and then we work out that the law of conservation of
So
momentum
is
works.
this going to be on next practical?
Sorry?
Is this going to be on next practical?
It's not going to be your practical. If one or two of you finish with this momentum problem now, then you can do this. And we'll film it, put it on YouTube by tonight, work out the velocities, and prove that the law of conservation of momentum actually works. You know what I think I'm going to do? If this suits you, let's just do momentum today and do chemistry tomorrow, because your test is only going to be on momentum for tomorrow. And I want to make sure you can do the momentum problems. Are you happy with that?
How many marks is the test session?
Look, let me give it to you and say, whatever this is, it's about 18. So, would someone mind? This is from 2016. So here's, we're going to give you that. That one is actually looks difficult, but it's not, I don't think. And on the reverse side is this one, which is from 20, I'm not going to tell you because you may go and look up the memo. I don't want you to go and look up the memo, and I've changed the values. So this one was from a recent year as well. So this one is a bullet going through a block, worked out exactly the same. Let's just make sure you can do this now. Happy with that? So then we know that you can do your homework. We know that if we give you different values, same test tomorrow, you're going to do well. Or I may just take this in for homework. So that's my original. Just see if you can do question 4 and ask any questions that you may have in English. Can I also make sure that I get this?
I'll finish it.
Then I can mark, give it back to you tomorrow, and then maybe the following day you can do a test on this.
You can take it so that already written the answers.
Well done, guys. I can see you really getting your act together. So I'll collect those. I'll collect these sheets.
We're gonna get late. So,
So try this problem.
She's lying now.
You guys think you know it a little bit.
You want me to clean this all?